Hello, this is PingPoint. In this video, I will provide 3 methods on how to convert binary numbers into decimal numbers. Binary is a base 2 number system having just 2 digits, which is 0 and 1, where each digit represents an increasing power of 2. Before we do the conversion, we have to understand the powers of 2. We have 2 raised to 0 is equivalent to 1. Any number raised to 0 is equal to 1. 2 raised to 1 or 2 times 1 is equal to 2. 2 raised to 2 or 2 times 2 is equal to 4. 2 raised to 3 or 2 times 2 times 2 is equal to 8. 2 raised to 4 is equal to 16. 2 raised to 5 is equal to 32. 2 raised to 6 is equal to 64. 2 raised to 7 is equal to 128. And 2 raised to 8 is equal to 256. If you have a good understanding of these powers of 2, you can pretty much do any binary conversion. So let's start with our first example. We have 1, 0, 1, 0, and 1. How we are going to convert 1, 0, 1, 0, 1 into a decimal number. The rightmost digit in a binary has a positional value of 2 raised to 0. Next is 2 raised to 1. Next digit is 2 raised to 2. 2 raised to 3. Then 2 raised to 4. Next is to cancel all 0 digits. We will not include them. Every time you see 0, you just ignore them. So next is to multiply the remaining ones. So 1 times 2 raised to 4 is equal to 2 raised to 4. Plus 1 times 2 raised to 2 is equal to 2 raised to 2. Plus 1 times 2 raised to 0 is equal to 2 raised to 0. 2 raised to 4 is equal to 16. Plus 2 raised to 2 is equal to 4. Plus 2 raised to 0 is equal to 1. So 16 plus 4 is equal to 20. Plus 1 is equal to 21. Base 10 or decimal. So 10101 is equal to 21 base 10. Okay, for our next example, we have 1, 0, 1, 1, 1, 0. And again, the first digit in a binary number has a positional value of 2 raised to 0. Next is 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, then 2 raised to 5. Next step is to cancel all 0 digits. We will not include them. Then multiply the remaining ones. So 1 times 2 raised to 5 is equal to 2 raised to 5. Plus 1 times 2 raised to 3 is equal to 2 raised to 3. Plus 1 times 2 raised to 2 is equal to 2 raised to 2. Plus 1 times 2 raised to 1 is equal to 2 raised to 1. Then 2 raised to 5 is equal to 32. Plus 2 raised to 3 is equal to 8. Plus 2 raised to 2 is equal to 4. And plus 2 raised to 1 is equal to 2. So 32 plus 8 is equal to 40. Plus 4 is equal to 44. And plus 2 is equal to 46. Base 10. So the decimal equivalent of 101110 is equal to 46. Okay, and for our next example, we have 1101101. The first digit is 2 raised to 0, then 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, then 2 raised to 7. Next step is to cancel all 0 digits. Then multiply the remaining ones. 1 times 2 raised to 7 is equal to 2 raised to 7 plus 2 raised to 6 plus 1 times 2 raised to 4 is equal to 2 raised to 4. 1 times 2 raised to 3 is equal to 2 raised to 3 plus 1 times 2 raised to 2 is equal to 2 raised to 2, and 1 times 2 raised to 0 is equal to 2 raised to 0. Then 2 raised to 7 is equal to 128 plus 2 raised to 6 is equal to 64. 2 raised to 4 is equal to 16 plus 2 raised to 3 is equal to 8 plus 2 raised to 2 is equal to 4 plus 2 raised to 0 is equal to 1. Then 128 plus 64 is equal to 192 plus 16 plus 8 is equal to 24 plus 4 plus 1 is equal to 5. Then 192 plus 24 is equal to 216 plus 5 is equal to 221 base 10. So the decimal equivalent of 1101110 and 1 is 221. So that's how you convert binary to decimal numbers using the first method, and I call it the regular method. Next, we are going to convert the same set of binary numbers using the second method, and I call it double the number method. So for our example number 1, we have 1 0 1 0 1. Under the rightmost digit, we're going to put 1. And as we move to the left, we're going to double the number. So this becomes 2, 4, 8, and 16. Next is to cancel all zeros and the numbers underneath them. Then get the sum of the remaining ones. So 16 plus 4 plus 1 is equal to 21 base 10. So we still get the same answer, which is 21 base 10. Then for our example number 2, we have 1 0 1 1 1 0. And again, we're going to put 1 under the rightmost digit. And as we move to the left, we're going to double the number. So this becomes 2, 4, 8, 16, and 32. Next is to cancel all the zeros and the numbers underneath them and get the sum of the remaining ones. So 32 plus 8 plus 4 plus 2 is equal to 32 plus 8 is equal to 40 plus 4 is equal to 44 plus 2 is equal to 46 decimal. Then we still get the same answer, which is 46 base 10. And for our third example, we have 1 1 0 1 1 1, 0, 1. Then put 1 under the right most digit, then double the number. 16, 32, 64, and 128. Next is to cancel all the zeros and the numbers underneath them. Then get the sum of the remaining ones, which is 128 plus 64 plus 16 plus 8 plus 4 and plus 1 is equal to 128 plus 64 is equal to 192 plus 16 plus 8 is equal to 24 plus 4 plus 1 is equal to 5. So 192 plus 24 is equal to 216 plus 5 is equal to 221. And again, we still get the same answer, which is 221 decimal. Easy, right? So next, we're going to convert the same set of binary numbers using our third method, and I call it the power of 2 table method. First, you have to write the power of 2 tables, starting from 1 from right to left. So we have 1, 2, 4, 8, 16, 32, 64, and 128. And for our first set of binary, we have 1, 0, 1, 0, 1. Then we are going to write this number just below the power of 2 table. So starting from the right, 1, this one, 0, 1, 0, and 1. We're going to delete this first. Next is to cancel all the zeros and ignore the number associated with them, and add up the numbers with 1. So 16 plus 4 and plus 1. So 16 plus 4 is equal to 20 plus 1 is equal to 21 base 10. And for our second example, we have 1, 0, 1, 1, 1, 0. So we're going to write these binary numbers under the power of 2 table. So this 0, we will put this here under 1, then 1 under 2, and so on. 1, 1, 0, and 1. We're going to delete this one. The next is to cancel all zeros and ignore the numbers associated with them. And again, get the sum of the remaining ones, which is 32 plus 8 plus 4 and plus 2, which is equivalent to 32 plus 8 is equal to 40 plus 4 is equal to 44 and plus 2 is equal to 4610. So using this third method, we still get the same answer, which is 46 base 10. And for our third example, we have 1, 1, 0, 1, 1, 1, 0, 1. So we will write 1 under the rightmost digit, 1, then 0, 1, 1, 1, 0, 1, 1. Then cancel 0 digits and ignore the number associated with them. Then add up the numbers with 1. So 128 plus 64 plus 16 plus 8 plus 4 and plus 1. So 128 plus 64 is equal to 192 plus 16 plus 8 is equal to 24 plus 4 plus 1 is equal to 5. Then 192 plus 24 is equal to 216 plus 5 is equal to 221 base 10. So that's how you convert binary numbers into decimal numbers using three different methods. Easy peasy lemon squeezy, right? And just choose which method works best for you. Thank you for watching, and I hope you'll find this video helpful. And please don't forget to like, comment, share, subscribe, and hit the notification bell icon so you'll be notified on my next video.